Hello class, how are you doing? I'm trying to evaluate a definite integral. I know this is indefinite, but I'm going to give you a lower bound and upper bound in a minute. Using numerical approach, you have two different ways. One of them is trapezoid rules. I'm going to do the trapezoid, and the other one is Simpson's rules, and we're going to talk about Simpson's rules in the next video. Whatever your lower limit and upper limit is, it must be part of your domain. Means I cannot give any number, left and right, that between them this function won't be defined. And this function must be a positive number, means the graph must be above the x-axis. Therefore, I'm going to pick a number here. I'm going to pick 1. I really want to make my life easy. I'm going to pick a number when I add 1 to it. It becomes even when I split it. If I put 5, what is 1 plus 5? 1 plus 5. Okay. Is 6. What is the middle of it? Is 3. What is the middle of 1 and 3? 2. Therefore, I'm going to pick 5 because I could split my number line my domain very easily. But the question is here, in the test, if I tell you for trapezoid, maybe your answer is not exactly the same as when we apply rules. Apply rules means change it to rectangles and delta x approaches 0. At that time when delta x approaches 0, maybe the number of rectangle you have is 4,000 of them. But I want to do it with trapezoid with only 4 trapezoid. Well, I'm going to easily go here and say, okay, I have a graphing calculator, and I'm going to say math, number 9, that's my integral, from 1 to 5. My function is the square root of x. Let's get out of the radical and say sine of x, close parenthesis, once. Because I have a trig function and 1 and 5 are real numbers, I want to make sure my mode is in a radian mode, which it is in the radian mode. Then I'm going to press enter. Is it my syntax? Let me see what is my, oh, I forgot to put respect to what? Respect to x. Therefore, I put my integrand, respect to x from 1 through 5. That's my answer. That answer is a negative. Is negative 0.586. Okay, let me go do my graph and say, what is my graph? Is the square root of x sine of x, and my window, my x is only from 1 to 5. I go 0 to 6. And I'm going to leave my y alone right now, and I'm going to say, what is my graph? Well, do you see what happened? Then my calculator died because of a low battery. Therefore, the number I pick, the number, it is in my domain, but it crosses the x-axis at some point, and that's the reason that area minus that area, and that's why you got a negative 0.5, because that area is bigger than that one, and the negative part is bigger. Let me see, find my x-intercept, which is number, the zeros, number 2. I said, okay, the left bound is 1, the right bound is 4, and my x-intercept is 3.14. The graph passes through 1.4. I have to have a positive number, therefore I cannot use 5. I'm gonna pick 3 because the graph must be positive. Okay, let's go right here and go to math and go up here and see if I can copy this and come back and change that 5 to a 3. That's good, 2.05. That's the positive number. Therefore, I'm going to go from 1 to 3. Therefore, do you see, creating a problem is not easy. 1 to 3. What is the middle of it? 2. Where is the middle of 1 and 2? 1.5 and 2.5. I'm going to do only for trapezoid. Then please watch what I do. And here, you can call this one Y0 or Y1. Y1, Y2, Y3, Y4, Y5. What is the upper limit? 3. What is the lower limit? 1. Divided by, I need a 2 right here because you have to average the bases, times B minus A over N. How many trapezoids you have? How many trapezoids do you have? 4. Would you tell me what is Y1? I'm asking what is the height of the function when x is 1. Therefore, this is this. Plus 2 of 1.5 sine of 1.5. Plus 2 of 2 sine of 2. Plus 2 of sine of 2.5. I'm sorry, 2.5 sine of 2.5. Plus 1 of, the last one is 1, square root of 3 sine of 3. And closed. I'm going to add all of these here. Somebody said, well, you're still using a calculator. Yes, sir, I'm using a calculator. But I know what sine of 1 radian is. You might don't know. I know what is the sine of 1.5 radian is. But somebody said, well, I'm going to use a calculator and just do like I did right here. Then when I have to go through here, don't you think if your major is a computer science, you should be able to write a program and that program go inside here and the student can use that technology? Then you need to know the constitution of every country, the rules of every approach that you be able to write a program. Then I'm going to do right here. Turn it on. And I'm going to put square root of 1 times sine of 1. I'm going to show you a shortcut. Okay, just watch what I do. I go to my function, and I'm going to type my function right here. That's my function. And what is that function? Y1. And look at how easy this is right now. You go to variables, y variables, function, which is number 1, and pick up y1. And put 1 right here. Because I'm doing it for 1. Plus, how many y2 you need? You need 2 of. I'm going to put this one into what? I go to variables, y variables, function, and put 1.5. Plus 2 times variables, y variables, function, y1. But what am I going to put in y1? 2. Do you see? I'm doing exactly those. 1, 1.5, 2. And in here I have an extra parenthesis. I'm going to delete it. And it plus 2, y1. But this time I'm not going to put 2. I'm going to put 2.5 plus, next is 3. I need one of them. 1 variables function y1 and a 3. Press enter. 7.99 times a 2 right here. 3 minus 1 is a 2. 2 and a 2 is gone. Divided by 4. Don't you know 7.99 is almost 8, and divided by 4 is 1.9998. What was the exact? The exact was 2.5. With 4 trapezoid, if I subtract 2.05 with a difference of 500th, with a 5 trapezoid, I took care of the business. Don't you think if I do 6 trapezoid, it becomes just like that? Then I want you to know, maybe the program inside TI 83 or 84, maybe it's a trapezoid rules. I don't know. But I'll let you know in the future. Therefore, this was example of a trapezoid rules. Therefore, I hope you enjoyed it. I know there is going to be at the end, by how many trapezoid you pick, there is some error. The error has a formula, is in the textbook. We're not going to discuss about the error, because error is depend to a number of a trapezoid. As the trapezoid get more and more and more, the error become less and less and less. Therefore, as long as the trapezoid is more than 8, pretty much is the error is going to be very insignificant. Therefore, that's not a part that we're going to discuss, but at least I gave you some ideas about, if you don't know any technique, you can use trapezoid rules to evaluate a definite integral.